Today in this video we are going to vary the brightness of this LED with the help of this rotary encoder, and the percentage of the brightness is going to be displayed on this OLED screen. And I will also explain you the working of this rotary encoder with the help of this mini simulation. So let's get started. So unlike ordinary potentiometers which has physical rotational limits like this one, these rotary encoders doesn't offer such kind of limits. You can rotate them continuously at any angle for as long as you want. So this rotary encoder simply outputs two signals, one through this clock pin which is also called as output A, and other through this DT pin which is also called as output B. And this middle pin is a switch pin. So when you press this knob of the potentiometer, the rotary encoder, you will also get another signal through this pin. But in this project we are not going to use this pin. So this is the internal structure of the rotary encoder, and here you can see that there are two pins A and B corresponding to CLK and DT respectively. And these orange patches are nothing but the common pin C, which is attached to the knob of the encoder. So whenever the pins A and B makes contact with the pin C, they output high signal, and whenever they leave contact with the pin C, they output slow signal. Let me show you the simulation. And this A and B pins are placed such that there is a phase difference of 90 degrees between both the pulses. Okay, so on the clockwise rotation you can see that the output A pulse is leading output B pulse by 90 degrees, and similarly on the counterclockwise rotation the output B pulse will lead the output A by 90 degrees. And we can determine the rotational speed of any device which this encoder is connected to by finding the frequency of these output pulses. And in this project we are changing the brightness level of the LED by determining which direction the encoder is rotating in. So that's how this rotary encoder works. Now coming on to the program of this project, we have imported the libraries related to OLED display and the I2C communication, and these are the height and width of the OLED. And here we have created the instance of this library Adafruit, and these are the rotary encoder pins, clock and the data. So clock pin is basically the output A pin and DT pin is basically the output B pin, and we are connecting the LED to pin number 9, which is PWM supported, because the brightness of the LED is going to be changed, so PWM will be necessary. And initially we are setting the brightness level of the LED to 128. So basically the analog write function outputs the value from 0 to 255, right? So 128 will be the middle value, that means 50% brightness. And in the setup function, the clock and the data pin are the input pin and LED is the output pin. And we are setting the LED with the brightness level using this analog write function. Now in the loop function we are reading the digital state of the clock pin, which is output A, and we are detecting whether the encoder is rotated or not. And we will detect only the rising edge. Rising edge means when the level changes from low to high of the clock pin. So if the current clock is not equal to the last clock, it means the level has changed, and the current clock pin is equal to high, it means we have reached the high level of the rising edge. And we are further determining whether the encoder is rotated clockwise or anti-clockwise. So if the digital lead of DT is not equal to current clock, it means the clockwise rotation, then the brightness will be increased by 5 each time. Otherwise the brightness will be decreased by 5 on the counterclockwise rotation. And we are considering the brightness value in the range 0 to 255, and then we are applying that brightness level on the LED using this function. And finally we are updating the last clock state with the current clock state. And it's not the case that we are bound to detect only the rising edge, we could also detect the falling edge. So for the falling edge, this high will be replaced by low, and here this not equal to condition will be replaced by equal to condition, and these two condition will be swapped like this. So this will be coming here and this will be coming here, and this will be replaced by clockwise, and here this will be replaced by counterclockwise. So by uploading this program you will also get the same output. Now this function is used to update the OLED screen, and we are mapping the brightness level from this range 0 to 255 into this range 0 to 100, and we are going to show this title LED brightness on the top of the OLED screen, and this is the percentage title. And the percentage bar is going to be drawn using this function draw rectangle, right? And the bar is going to be filled with this variable bar width, which is nothing but the brightness in this range 0 to 106. So you will find more such videos on my channel, so make sure you subscribe to it and let me know in the comment section what next project do you want me to build in my next video. And thanks for watching it.